So last day we have discussed about the hazard of a pipelining, and we have seen that there are three types of hazard present in a pipeline: data hazard, control hazard, and structural hazard. Where data hazard deals with the unavailability of data, control hazard actually due to the branch instruction, and structural hazard is actually the resource conflict, you can say. So we have seen an example also for the data hazard and the control hazard. So now you will start with more detail of each and every hazard. So we will the topic for today we have for is data hazard. Now what is the definition of data hazard? I am not going in detail of that because already you have the of that idea of what a basically data hazard is. Today we will start with a detailed view of the data hazard. Depends on various situation, depends on the unavailability of data in various condition. This data hazard actually categorized in mainly three part. So one is called read after write hazard. The second is write after read hazard, and third one is write after write hazard. So in short we say it's as raw, RAW. This is called WAR, and this is called WAW. So we will go through the three different type of data hazard one by one, and we will see what does it mean. So let's start with the first category of data hazard, that is read after write. So first of all, what does it mean? You see, suppose there is two instruction I1 and I2. I1 is followed by I2. So I1 is the first instruction, then I2 is the second instruction that will be entered in the pipelining. Considering this scenario, we will try to explain this different hazard. Okay. So what this read after write hazard say that I2 tries to read a source before I1 writes it. So what will happen? So naturally I2 will get incorrect value. What does it mean? You see, it means that if I say that we have two instruction I1 and I2, I mean, let's take a different color so that you can distinguish the. So suppose there is two instruction I1 and I2. I1's mean add B and I2 mean add C. You see, these two instructions are really exists in 8085 microprocessor. So I'm taking a real life example for this case. Okay. And what does this add B means? This add B means accumulator content will be added with with the register B, and result will get stored within the accumulator again. Okay. And similarly, this add C means ACC, that means accumulator, that is equal to accumulator plus C. That means accumulator content will be added with the accumulator content will be added with the C, and the result will get stored in accumulator again. Now you see, if this data is entered in the pipeline one by one, then what will happen if I draw the corresponding diagram for the pipelining situation? What you will see, that if I have fetch, decode, execute and write back, four stages. So let's draw in this way. So these are the time, and we have a so this particular table is a reservation table representing the pipeline situation for this case. Now let's draw the timing 1, 2, 3, 4, 5, 6. So these are clock cycles. Okay. And what we know, that obviously fetch of instruction 1 will start because it is the first instruction, F1. And then when decoding of instruction 1 will start, the fetching of instruction 2 you can start at the same time, right? And then when the execution of instruction 1 will start, you can start decoding the instruction 2. Up to this is okay. But now you see, when this execution will complete, execution of instruction 1, and it will enter in the write back stage. What does it mean? This write back stage means the writing back the result. Now what does it mean with respect to this instruction? Writing back the result of this addition within the accumulator again, right? Now interestingly, if you look after the second instruction, when W1 started, naturally the execution unit is free. So you can say that you will use the execution unit to execute the second instruction. But if you look upon the second instruction, it says that accumulator content will be added with the content of C and stored in the accumulator. Now, when as a programmer you are writing a program, maybe you have written the program in such a way that first B, content of B and accumulator will be added and stored in the accumulator, then the updated content of accumulator must be added with C, right? Because with respect to a programmer, the line that you are writing, whatever language you are using doesn't matter, is basically sequential. Programmer doesn't care about how the processor will execute the program. I mean, whether there is a pipeline condition or is there any hazard or not, right? So naturally, the the programmer will expect that the updated value of the accumulator will be used in the second instruction. But if you continue the using execution stage for instruction 2, then what will happen? When the accumulator content is updated before completion of the updation operation, the accumulator is basically used by the second instruction. So naturally, the second instruction will not get the updated value of the accumulator. If you want to get the updated value of the accumulator, somehow you have to restrict your pipeline to execute this second instruction in the execution stage until this write back completes. When the write back will be completed after fourth clock cycle, then only you can start executing the second instruction, and then you can get the actual, I mean, you can say the updated value of the accumulator, and then you can find the correct answer in the accumulator in the write back stage of the second instruction. So what observation we can find out, that we have seen that there is a bubble, right? So this is a bubble, or you can say this is a bubble. So this is a bubble which happens due to the unavailability of this accumulator, right? So this is what just you actually the same example we have discussed in the previous class, that is written over here. However, we have not yet defined over there at that time what type of hazard it is, but the discussion as an example, what we have seen in the last class is basically an example of a read after write hazard.